computer distant, computer better. Everybody let me dance, get flatter. Computer distant, computer better.
Hello, beautiful friends of the internet. Welcome again to another exciting episode of Dead Program Live at La Pipa. Hello, fellow cyborgs. Hello, humans. Hello, robots, in whatever binary you happen to speak this month. And, of course, hello, extraterrestrials. Come get us. We're waiting for you. So it's been a very exciting week. Lots of things happening in the world of technology. And, of course, as always, I am loving to start with news from space. Space, 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 space. Oh, yeah, space. So many of you know that I am very, very eagerly awaiting the installation of my Starlink satellites. And, of course, my favorite evil genius, Elon Musk, does not disappoint with another launch of satellites. This is 60 satellites being released a couple of days ago from the latest SpaceX launch.
There you can see and hear that call out that the Starlink satellites have deployed as they are drifting away from the second stage.
Starlink satellites deployed as they drift away from the second stage. And hopefully one of those will take station above Western Europe, where it will start transmitting to the dish that I am eagerly awaiting the receipt of. Yes. So further away, on Mars, there's been lots of action, and we've all been following with great anticipation more flights of Mars Ingenuity, which is the awesome multicopter that's flying on Mars. So this is some video that is from last week's flight, and this is pretty amazing. So you see over here on the left, you can see the drone. It's about to take off. There's no audio because, there's no air on Mars. Right. And so here's the takeoff. And this was the longest and boldest flight yet. Uh-oh, it's streaming. It's looking for Google Ads. What's it doing? I hate when that happens. Maybe I'm connected to the wrong Wi-Fi network. Oh, yes. I need to connect to a different network. A better one. One that's got higher speed. There we go. Hopefully this is still working. Maybe we need to replay. Uh-oh, did we lose connection from the internet? Or are we still around? No, it's still trying to connect. I hate when that happens. There we go. All right. Yeah, so there it takes off. The Ingenuity's third flight. It flies off the edge of the screen of what we can see. And it's still flying. That's why this video keeps going. Eventually, it's going to come back from the right edge of the screen and come back in for a landing in its original spot. Let's see if that actually happens. Hopefully. Yep, here it comes. Yes, Ingenuity coming back in and then coming in for a landing. A very nice soft landing. Stuck the landing. That's really cool. So I was wondering, how far away did that drone actually get? And this picture taken by the drone shows you in the distance here, you can see this is the rover right here. Okay, this is Perseverance. This is the furthest extent that Ingenuity flew to. So that is pretty incredible. So they tried to do another flight this week, 2 days ago. Actually, yesterday I think it was. But unfortunately, it didn't work out. No crashing, but something went wrong with the takeoff sequence. They aborted, and they are going to try again, I think maybe tomorrow. Not sure. I think it's tomorrow. Anyway, so that's very exciting. Very cool stuff. We're pretty excited to see anything happening there on the red planet. So This week, I thought we would try a slightly different format. Let me find my mask here. Here we go. So I'm going to invite my friend Lorenzo, who is just starting to learn Go, who is going to participate in what I am going to call Learn to Tiny Go. So,
Hello.
hey, how's it going?
I'm
Welcome.
fine, thank you. Hello.
Thanks for coming. So
My
let's
pleasure.
switch back to the main camera. So I heard you wanted to learn to program Go. Is that true?
Absolutely. Yes, you're right.
You program in a lot of other languages now, though.
Yeah, well,
Python,
yes,
C++.
Python is my latest one, and it's very good fun. I actually tested MicroPython in last year to do something with embedded devices, but Go and TinyGo, I'm totally new with that stuff. So I'm really curious, and I hope I can see something and do something.
Cool. Well, yeah, we really like MicroPython and CircuitPython. Ike Van Latham, who is the original founder of the TinyGo project, he's contributed to MicroPython, and we really like the work that they've all been doing. And we have a different idea, but definitely the TinyGo, as you'll see, is definitely influenced by the work that they've done. So probably the best place to start is usually with a Hello World program. What do you think? Let's take a look at Hello World. So Hello World is the usual program that people write just to test to see, like, is the programming language that I am using, does it actually work to do anything? And so in Go, Hello World is very similar to Hello World in other programming languages. So this is main.go, which is a program which is going to be our Hello World. So the first line we have is package main.
So what's package here? It reminds me something, but I don't know what it is. What's package?
So a package is a collection of code that's all grouped together that does some type of purpose that makes sense for it to be grouped in that same package.
I see. So, and then main probably, well, I don't want to guess. So you tell me, please.
Well, package main is the main package. In a Go program, the main package is the starting point for any of the code that you write. It's when you first run the program, it starts in the package main.
I see, I see. Well, another thing that I might try to guess, but I don't want to still be wrong. Func. This sounds me something similar in Python, but I'm not sure if that's the equivalent, for example, of
Sure.
def.
Well, func is short for function, and a function is a group of lines of code that are going to be executed sequentially one by one, and then when they're finished, it's going to return from that function back to the original place that it started. And so function main,
Yeah, with these two parentheses, does it have any relationship with the package then, I guess?
well, when we say function main, we mean that it's the main function that's going to be executed by the program. And in Go, every function needs to have some parentheses in case we pass it some information. We want to tell that function some information, like if we want to get the square root of a number like 4, we would say square root open parentheses 4 close parentheses, and that would return hopefully the number 2.
I see.
In this case, because it's the main function, it doesn't actually return anything, but in order to be proper Go programming language, we need to put in these parentheses here. And then we have the squiggle brackets, which mean the beginning and the ending lines of that function.
I see. Well, I won't ask you println because I guess it's just to print some sort of string, but here we are in Go and not in TinyGo, so I guess this string will go out into the standard output of the terminal.
So this is a Go program. It could also be a program that's executed by TinyGo, and if we run it on Linux, it would have the exact same output whether we run it in Go or we run it in TinyGo. So the way that we run a program in Go is we say go and then run, and then we put in the name of the program we want it to run. So in this case, we'll say hello world demo hello world main go. And so when we run that, it outputs to the terminal hello world.
Beautiful.
So TinyGo is a compiler that can compile Go programs. And so if we say TinyGo run, and we run that same program, it'll do the exact same thing.
I don't understand that. Why? I mean, how can you see that on the standard it if it's you are running it onto a microcontroller?
Well, we'll do that next. But the other thing that's worth knowing is we have another Go command, go build. So go build is if we want to create an executable version of the program
Oh, see.
and then run it at a separate time, because Go is a true compiler, not like Python. With Python, you have to have the Python interpreter and you have to have the Python code. With Go, once you've compiled the Go code, it's just a normal executable that you can distribute that file anywhere that it could be executed, and you don't have any other dependencies. It's just that one file.
I see.
So if we say go build -o, and then we'll say it's hello world .go 1.16, just so that I know the diff. And then we compile again our demo hello world main. Then that builds this program, and we can see if we do an ls-l for long, that this Go program that's hello world is about 1.2 megabytes in size. And if we execute it, then it just runs hello world.
Okay.
But that's kind of big. Now, a Go program contains no external dependencies. So you don't need to provide any other libraries or other things. Everything you need is in that one file. So you can give that file to somebody else who's on Linux, and they can run it, and they don't need to install anything. They can just run that program. So it makes it very convenient to distribute code. So if we do the same thing with TinyGo, and we build, we say TinyGo build, and this time we'll create a different output file. We'll say it's TinyGo, I think it's 1.17. So then if we look at that, we can see that the TinyGo program is 35K.
I see.
So a normal Go program for Hello World is 1.2 megabytes, and a TinyGo program that does the exact same thing is only 35K. So that's pretty tiny.
Fantastic.
So, and when we run that program, we should probably make sure that that's still actually, it also does the same thing of output to Hello World. So,
Okay, so still here we are on local. So this object is what you flash directly onto the device, or still there is some intermediate step?
well, we just built a TinyGo program that runs on Linux. If we
Yeah.
want to run a TinyGo program that runs on some other type of architecture, then we need to tell our TinyGo program when it runs that we want to build it for a different target. In other words, we would add to this the flag target, and then we could specify if we want to build it, for example, for a microcontroller, we could say the Arduino Nano 33. So it just so happens that I have an Arduino Nano 33 right here, which would be nice if I focused a little more, maybe. So this is an Arduino board made by Arduino, but that uses the Atmel AT-SAM D21 microcontroller, which is a 32-bit ARM microcontroller, an ARM Cortex M0, and then it also has separately on board an ESP32 microcontroller for Wi-Fi as a coprocessor. So it's got two different processors on one board. So it's very nice board for doing different types of prototypes. And also, this board has, even though I have pins in it to put it in this little breadboard, it has a scalloped edge, so if I wanted to use it as part of a product, I could just create a mount for it and just mount this as a separate module in some other type of hardware. So it's really the first of a new generation of Arduino boards that they introduced about 2 years ago, about a year and a half ago, I think now, in order to, provide a slightly more industrial, more robust, not just, fun maker cool stuff, but also something that was, a little more oriented towards a professional, which they've been doing more of that since then. So if we want to flash Hello World on this board, we would just do the same thing, but we would need to plug in this cable so that we can plug the microcontroller into my computer. So I'll plug that in, and I'll plug it in.
So does it have the USB driver processor incorporated on this one, the UART thingy, probably?
Yeah, so the AT-SAM D21 is got a built-in USB port, which by using the USB Communication Data Control Protocol, or CDC, we can basically use the USB port as an actual serial device, like a UART, which is sort of its original purpose. You can use them for other things as well, like a mass storage device, like when you plug in the USB drive, where it appears with files, or there's a human interface device, like a mouse or a keyboard. We don't support those yet. We just support the USB CDC, but it makes it so that instead of building and flashing separately, all we have to do is say TinyGo flash, and then TinyGo flash knows that for the target of the Arduino Nano 33, that it needs to use a special program to flash it that it's already got embedded into it.
Okay,
so when I do this, it will recognize the board,
so you
compile it, flash it, and then puts it onto the board.
So you have to prepare the board first, somehow, or it doesn't require any special. You just flash it, and
yes.
Okay.
So the bootloader is the program that runs on one of these microcontrollers right when you first turn it on, and then it usually loads some other program to do whatever useful work. And that way, if you want to change the working program, the user program, the bootloader is there in order to do this substitution. So the BOSAC bootloader, which is included on these boards, is already flashed on it when you get them from Arduino, so you don't have to do any other work.
Exactly.
It's ready to flash. You just plug it in.
So you get the vendor one directly, no special.
Exactly.
Okay.
So it makes it a lot easier than, I know you've worked with a number of just bare boards. The first step is usually you have to put some type of bootloader then,
exactly.
and that can sometimes be very tricky.
Okay.
As a few weeks back, we tried to do that on one of those boards, and I failed. But I'm ready to try again sometime. Not today,
Absolutely.
maybe, but I'm ready to try again. Ready to try again. So, how does this work? I mean, where do we see the output? Well, in order to do that, we're going to need to use a serial port of some kind. And so, if we run the serial port, the problem is that there's not actually the code already ran. So it's too quick for us to be able to, actually see it do anything. Maybe if I think it's just a little too quick. Or maybe it's not even seeing it. Well, the thing is, usually with a microcontroller, instead we would do a slightly different hello world. I like to call it the hello world of things, and it's a blinking light, a blinking LED. That's usually how we know that it's working or not. And so, if I go back to my, where was it? D9, I think is, I should call this hello. keep my TMUX tabs slightly more organized, if I can just remember where they all are. And then let's look at the hello world of things very briefly. So now at GopherCon 2019, we started doing our first in-person workshops, and we had a couple hundred boards that Arduino provided for the attendees and a bunch of other cool hardware. And so we have a self-guided set of lessons on a GitHub repository, and this is step 0, the first of them, which is this blinking LED. So the way that it works is, and we can make the font a little bigger.
Yeah, I see you are importing something else. Well, package main, as we've seen before, I guess it's more or
Exactly.
less the same, but then you are importing machine and time. I guess
So yes,
Machine?
import machine is part of TinyGo itself. And the machine package is a special package that TinyGo creates, which is the hardware abstraction layer. It lets you control LEDs or pulse width modulation or the I2C devices to use for displays or the SPI devices to use for peripherals. It basically provides a uniform API,
yeah.
and that way whichever hardware you happen to use, the machine package, as long as it's hardware that's supported by TinyGo, then you'll be able to just import the machine package and it will let you access that hardware. And then the time package is part of the standard Go packages, and it is how we keep track of time to know how much time has elapsed, or in the case of this program, if we want to sleep, which is to wait for a period of time before resuming the execution of the program.
Okay.
So let's take a look at our function main, which is the same idea. It's the primary function that we enter.
Sorry if I ask you, but if you sleep, it's really a hard sleep on the device, or is there is some sort of extra circuitry to keep those counter alive, or is just a very soft one, and let's say that the consumption of the board will keep
So the way
it's
that
working.
yes.
Okay.
So when look, TinyGo, because it uses the LLVM compiler, it is able to compile code for this kind of 32-bit ARM microcontroller, and it's able to take advantage of the capabilities that these 32 ARM microcontrollers have for doing limited forms of multitasking. They only have a single core, but by taking advantage of basically the microcode that's actually built into all of these ARM processors, we're able to execute concurrently even with a 32-bit microcontroller. So when we go to sleep, when we say time sleep, we actually are letting other Go routines, other simultaneous things happen on the same microcontroller. And this program does not do any of those, but I have other programs that do, and we'll get into that in the future. But let's finish going through the hello world of things. So the first thing we have here is we say LED, which is a variable named LED, and when we say colon equals in Go, it's very much like the colon equals in the programming language Pascal. It both defines and assigns at the same time, and because Go is strongly typed, it looks at the type of the thing on the right-hand side to determine what the type of the left-hand side should be. So instead of having to declare the variable and the type and then assign it, it lets us do it all in one line of code.
So this is optional behavior. I mean, you can let Go infer the type with that operator.
Yes.
Okay.
That's what this operator is designed to do. You could also define it as a variable of a particular type and then assign it. But because Go has got a very strongly typed compiler, it's able to do that type inference very well at compile time.
Okay.
So then we tell that LED that we want to configure it, and that we're going to configure it using a pin configuration structure, A structure is a group of data that's related together, similar to a struct would be in the C programming language. And then we're saying that the mode to use for this configuration is pin output.
Okay.
So we're saying the LED should be configured as an output pin.
Okay, so I guess you have outputs, inputs. There is anything else in between that we can analog or something like that, for example?
There's other types of configurations, but we don't have to worry about that right now. But yes,
Okay.
other types of pins would have other types of configurations. So then we say for, which in the Go programming language, there's only one way to do a loop, and that is for. In Python, you have while, and you have for, and you have do until. In Go, you only have one thing, and that's for.
Okay.
And so for can, in this form of for, it does not take any additional parameters. It means basically forever.
Okay.
It's the same as saying while
While
true
true,
in
right.
Python. So it's just going to keep doing whatever's in between over and over. So the first thing it does is it will say LED.low. So LED.low will turn off the LED. Then we say time.sleep, which will do the sleep that we discussed before for time.milliseconds times 500. So in Go, that's a way of we saying 500 milliseconds. We say 1 millisecond times 500.
Okay.
And we could do that in either order. We could say 500 times time milliseconds. That I usually do that because it reads a little more nicely.
Okay.
And then LED.high, which turns on the LED. Then we time.sleep again, this time for another 500 milliseconds. And then we reach the end of the for loop, so we just repeat this over and over forever.
Okay.
And that's the whole program. So if it works correctly, and I think I have this same program in this other directory, and you can find it on that repo. Let's see here. Blinky, yes. So here's the program in my repository. And so if I go over and I use that same tinygoflash command with the same target Arduino-Nano33, but this time instead of compiling Hello World, I'm going to compile Blinky. And it is plugged in. So let's see.
It's
because I need to have the main function,
Yeah,
yes.
the directory.
And I don't have a serial port. Something went wrong with this board.
Try to list it. Maybe it's configured on the wrong one. No.
Some of these boards, there were a few boards that were bad in the original batch. They had literally just arrived from the factory at the GopherCon.
Okay.
So it's possible that this is one of those boards. Flashed it before.
Some speed setting on the.
No, it's some of the boards got.
No way.
Of course, right. We almost had it flashed. I forgot the other ones. I had a few I was going to bring. I know there's a way to do this with a jumper cable. And once we have it flashed, then we won't have to do this again because it'll automatically pick it up. That was how we flashed it earlier. But I probably, I believe the problem was when I flashed that Hello World that it's no longer waiting to do anything. It just exited that program right away, which is kind of undefined behavior on a microcontroller. On a microcontroller, what does it do when the program is over?
Loops forever, no?
It should do something,
Okay.
but it doesn't. We didn't program anything in. It just printed Hello World and left. We would normally need to put in some sort of loop on the microcontroller. I didn't think about that when I flashed that program.
But you are reflashing it, so everything should be.
Well, right, but there's no loop
I-
in there to look to see if, in fact, so we need to trigger the bootloader. So let me see if I can remember how to do that.
Flashing again, no, from the factory.
No, you can jumper it with a. There's a way to jumper it from. I forget which pins. Let's see. Let's see. Jumper pins Arduino Nano 33. I guess maybe bootloader. Let's see. Oh, we don't have to do this. We just need to jump it.
Yep.
Maybe if I put jumper?
No, you okay? Select this one. Burn.
But did you see something?
No, but it was wrong with the way you wrote it. So. Okay. But this is just to re-flash the bootloader, I guess.
It's actually to trigger it to go into the bootloader mode. We don't need it. This is, and we don't want the Nano. We want our Nano 33. I knew how to do this, but I forgot.
Maybe.
Oh, what? You saw something? I got it.
Yeah, I saw something probably. They were saying Arduino Nano IO33 losing the serial.
That's a different board.
Yeah, but
Oh,
it's
but this
compatible. It's very similar, I guess. So if probably the problem will be the same. This is the IoT and that one is the BLE, but it's 33. So
They're different
okay,
processors entirely.
Okay, sorry.
That is very confusing to people.
Absolutely.
You're absolutely right. In fact, somebody just mentioned that in our Slack channel. They were like, I was trying to flash it and it didn't work. And like, oh, yeah, actually, those are two different boards. Let's see. I want to say Bossack. Bossack and then Jumper, maybe. I should have left Jumper in there. I remembered how to do this, but I forgot. Oh, wait. No. Let's see. This is when you're looking at your own instructions, because that's what you find on Google, you're really hurting. I'm trying to remember which one. I think it was like the... If we look at... I think it was the reset pin, maybe?
To ground.
Yeah, I can't remember if it's to ground or to hot. Let's see. Arduino Nano 33OT Jumper Pin Bootloader.
Everything points to reflashing, which is what...
Well, yeah, that's what we're going to do, but once we trigger it, if we boot it with this jumper, then it will boot. Oh, wait, here we go. This is it, I think. No, this is using the J-Link, which I don't want to do.
no.
You don't have to do this. I just can't remember which pin it is. Remaining reset from reset to the ground pin. I believe that is the case. Well, we can find out relatively quickly if I can find a pin or a jumper. Let's see. This looks like a cable. Yeah, that would be a cable. So I believe that if I connect it, what did it say? Reset to the ground?
Yeah, I can see it. You want to do it under the...
Oh, yeah, that's a good idea.
Yeah.
We should definitely do that.
Exactly.
Oh, and also the silk screen of the pins is not on this side. That was a little problem because the components were so close to each other. So the
Okay.
Reset is
The
right next to
second
the
one
ground.
from the left on the lower.
Here.
Yeah.
And then to ground?
The
it said?
next one on the right.
Okay. So if we
Show.
load, so in theory that should maybe do it, right?
Boom.
If it doesn't explode.
Some atomic mushroom.
Can't tell if it did anything or not.
Did you? Ah, yeah. US or something?
No, it did not appear.
Maybe you have to remove it now, or
Maybe is it
reset.
reset to ground or was it reset to hot? Let's go back to that page we were just looking at. That looks interesting. Nano 33. Press and release or momentarily connect a wire between ground and reset. Oh, well, maybe that's a problem. But I need to basically do this. Or just connect it once. Uh-oh. Maybe this cable's bad. It's just hanging by a thread. Let's see if I have another cable. This one is for the trash. Let's see. I have a lot of them, but I may not have them here. Easily findable. Oh, I know where I have them. In the toolbox, of course. Or not. Not in this toolbox. Oh, I have a jumper here I can use. Here we go. Alright, let's try this again. So it was between this pin and the ground.
Yeah, the box, the white box is the momentarily. Yeah, now it should be with you maybe. No? Wait, okay. No. You give a reset again. It's blinking.
Yeah, no, it's
It's not that.
no, it's in the bootloader mode now.
It's okay,
I'm just not sure why it's not. But let's go back to where we were flashing it from here a minute ago. No, because the light, when that light is pulsing, that means that usually means it's ready to receive code.
So
That means it's in the bootloader.
we
mode.
probably raised the.
No, it's something else. I think what we can try is let's try to do that again. Also, make sure the cable's plugged in well. So it was, I guess, we plug it in and then just pull it relatively quick.
Give it to me.
Okay.
Oops.
All right, ready?
Go.
No, it didn't. The light did not appear. So that was definitely not it. Oh, there we go. You see that light pulsing?
Yes.
That means that usually means it's in the bootloader mode, because that pulsing is what indicates it's ready to receive code. But we're not seeing the actual port appear. So that is definitely suspicious. And I think the problem is this button is a little flaky from the factory. 'Cause that was what the problem was. Some of them, when we pressed them down really hard, when we double clicked on them really hard, then they would come up with the bootloader. Well, I guess I'm going to have to find another one in my pile of boards for us to actually finish this task. So we're still on step 0.
Yeah.
I'm not going to give you this one because this one's no good.
This is headache.
So I'll give you another one. I'll bring another one next week, and we can
Perfect.
go back to step 0. I was going to give you this one, but I don't want to give you a defective board.
I will be frustrated because I
So-
don't know if it will be me or the board.
Yes. No, this time it was the board. So, but at least I'll give you a sticker,
Thank you very much.
an Arduino sticker, and then next week I'll bring another board, and we'll be able to finish that. And then we'll also do step 2 or step 1. I call that step 0. So, I mean, you can keep the board anyway, even though it's like no good.
Yeah, we will have a
But
go.
for all I know, you'll unsolder and resolder the switch, and you'll have it fixed by next week.
Yeah. Perfect.
Cool. Well, hey,
Thank you very
thanks
much.
for stopping by, man.
It
Really
has been a
appreciate it.
pleasure.
All right.
Thank you.
All right. We'll see you next week. Well, that was fun. Almost got it working. So unfair. So unfair. No, I had a bunch of boards with X's written on. Not a bunch. There was like 2 or 3 or maybe 10. I mean, we had a lot of boards. So I'll take off my mask now that it's just me and GopherBot. So let's go on to some slightly more advanced activities. There were some cool things that we started last week that I wanted to work on this week to finish up. And the main one, of course, is our awesome NVIDIA Jetson Nano Developer Kit. Too much glare. Go to the main camera. Jetson Nano Developer Kit. Yeah, so this is actually a really cool board. It's basically like a Raspberry Pi, but with a GPU on board. And if you were with us last week, you saw that I started the unboxing and I began the process of installing the OpenCV 452 update on it, which I took about 2 hours. It actually took a little over 2 hours to compile that code, but it was successful. So I thought this week we would finish the task of taking this board and putting it into this cool case I got, and then boot it up and see if it's actually working as expected. So last week I took the case apart, saw there were a lot of parts, realized that we had to do a bunch of software installs, and decided that instead we would just focus on that. But this week, I think we should move further along and actually, now that we've got the software running correctly, so I have the assembly instructions here in Technology English, which means you have to look at the diagrams very, very carefully. So the first thing we want to do is install these switches. We have a power switch. Let's look at the micro camera view. Maybe we can see that a little better. So there's a power switch. You've got FR mode. Not sure what that does. Reset, and then the jumper. Oh, FR mode is factory recovery mode. Well, they could have just said factory recovery mode, maybe. I don't know. Anyway, let us take some of these switches out of the... We've got this fan. We've got tweezers. These, I believe, are the switches in question. And this looks more like a power switch to me. I mean, this is, I've got the power. Yeah, that's definitely power. It's got the universal logo for power. And then these are like the other ones. Which one is the universal factory reset logo? It's one of the two. It's either reset or factory reset. You be careful. I think maybe I won't connect the factory reset button. I don't know why. That seems like no good could come from that, and possibly some definite harm to my settings. So let's connect the power switch first, which it looks like it is over here on this side of the board, where the pins are kind of neatly hidden. And so we've got the power button on the ground, and generally that would be these two: power red, ground black. So we'll put it in this way. Okay. And then it's got these pins for the LEDs, the plus and the minus, which generally we will see, usually plus would be blue and the minus would be the gray, but they're showing it the opposite. So, okay, go figure. So gray is plus on this LED, and blue is minus. Okay. I think this little insulator is supposed to be protecting this cable here. Alright, so we got the power switch. Factory reset mode, I think we're definitely going to pass on that. Hard pass. Reset, though, I'll go for that. So the reset button is connected to where it says system reset, red, and then ground for, okay, we got that. And then this jumper. The jumper, I don't actually see a jumper cable in here. Maybe the jumper is just meant to be put on the way we did previously by attaching it directly to the, I'm trying to see where, auto on, disable. I don't see any jumper that resembles, so I'm just going to, I guess, do nothing. Okay, fair enough. Step 2. We put this in through the case. We've got the top here, and so I guess the power goes in the front here, and I will generally speaking, we would normally have done this by putting this through, taking off this housing. In fact, yes, we're going to have to do that. So disconnect the cables. They probably should have had you do this first. Otherwise, we don't have any way to pass the cables through the part of the case and then attach this screw, or this nut rather. And this way we can attach the power button here on the back and align it. Sure. Power up, power down. I don't know, I feel like it's supposed to be up. So we'll do that. Screw that in. And then reattach those cables. This one was the power button and reset. And then these ones were the LED, where blue was actually the minus and white the plus for some reason. Okay, so we got that in there. And then this is the system reset, not factory reset. And in similar fashion, we actually have to remove it to put it back on, since the only way to make it go through the case and stay is to remove this nut. So we'll take that off. We'll put it through the button that says reset. Probably don't want to use that too often from its positioning. We'll put on the nut here, lock it down. And there's our reset button. So now we just need to plug in the cables for system reset and ground, which I believe was these ones here. Yep, okay. So far so good. Alright. So power switch, LEDs, jumper, connect to auto on and disable pin. We didn't actually have that jumper. System reset, and then the power button. Okay, so now the fan. We have two fans. One is a case fan, and the other one is the fan that actually sits on top of the heatsink. So when we take a look at that, we can see how does it actually attach. There's some screw holes on the top of the heatsink here. And then there's also holes on the fan, and we need to make sure we orient it correctly so that the fan is, I don't know if it's supposed to be which direction. It looks like it goes this way. That would appear to be correct. And then that's going to need to plug into J15. And so jumper 15, as we can see from this, is, where is that? The fan on the side connects to the 5-volt red. The fan on the top of the heatsink connects to jumper 15, which is this larger jumper located right here. And we could probably see it labeled 15 if it's yeah, it says right there in very small print on the silk screen, J15 fan. So we can plug this in. It only goes one direction. It won't fit the other way, to prevent you from doing damage to your fan. Okay. And then we will want to take this and screw it down onto the fan housing. See if we can guide this through here a little better so it stays put. Yeah, that looks good. And then that probably looks like a good angle right there. So in one of these bags, we will have some 4 long screws that should attach the fan to the top of the heatsink. And it doesn't look like there's any washers or anything, so we just screw it right on, like this. And it came with a little screwdriver, conveniently, so we can hopefully guide it into place. Doesn't have a very long, that's really short. I think this is the opposite of how it goes. I think it goes this way, and the reason I think that is because the countersinking of these screws, there's enough protruding now that it will actually screw in, so that must be the direction it goes. So that was nice. It was not labeled, but it was actually made in a way that it could only fit one direction. So now let's screw in the rest of these. Coming right along, coming right along. All is going well in the world. You know, this is a cool case. And the thing is, you actually do want to have a really solid case and power supply and fans, because usually these kinds of devices, you run them for a while and they get very, very hot. Unless you have some type of fan system to cool them off, they'll definitely burn out. It's a small form factor computer, but it's not cheap. You know, certainly. Doesn't seem like it's going in. Oh, that's because we actually are going to need to use these nuts. So of course this is not going to be quite so easy, because instead of having tapped screw holes on the top of the fan housing, instead they just left you room to use these little nuts that they did include, to be fair. Probably that's a better setup because there's less chance of stripping them, but also it's a lot more of a pain because we need to guide in the nut. Usually there's just not, it's a little too long. Well, we'll find out. So if I put the nut in the hole and I guide in the wrong hole, it's the top one. Oh, no, actually that's definitely not going to work. Let's see. It would definitely be nicer if this was a little bit more... oh, this is why they've included these. So they provided these tweezers because that's going to be the easiest way for you to guide in the screw. We're going to have to use the screwdriver at the same time. And if I do this right, if I get this in there right, then it should, not quite. Maybe we can see it from the bottom side a little more easily. Oh, now I've dropped the nut again. I have worked in a factory, but not assembling electronics. You know, I worked on the software, and I still do, actually. And this is probably why. I'm sure there's a better way to do this, I just don't know what it is right now. Whoop! He went flying. Maybe if I hold it a little bit more snugly. Nope, too far. I have to hold it near the edge. Almost there. This is only one. I have 4 of these. So far, no luck. Maybe we want to try a different approach here. It's definitely the right size. I mean, there's no other longer screws, so that has to be it. Yeah, no, that's definitely it. The only other possibility... no, that can't be a possibility. We can't put the screw on the bottom and the nut on top, because then we will have no way to tighten it. So now this is it. This is the way. Unless, of course... no, this has to be the way. There is no other way. Not the best design for this housing, I think. Only because it's very hard to screw it in. Alright. Let's try it again. Once more with feeling. It doesn't stick out very far. I mean, it's hard to believe that that is the right part, but there are no other parts included. So, I mean, that has to be it. It's just does not fit in there too easily. Especially with all these other cables attached, which we could disattach. In fact, let's do that. We can plug that back in later once we have the actual fan housing on this. Alright, that's definitely better. So let's see. Here's our nut. And to... It definitely does not have a lot to grab onto. I mean, that's pretty short. No, it's long enough. You just have to do it very, very carefully. You really gonna want to do this, don't you? But as I said, if you don't put the fan on, it's gonna get really hot. I mean, you're gonna put a fan on this, yes or no? The question is, are you gonna do it with this particular fan? And if so, let's try and get it on the other side first. It definitely doesn't give you much room. You see, it barely, it doesn't have a lot to seat on. That's part of the problem here. Is these probably could be a little longer, because you could see, if you can see this, the light is on enough, but you can see that the screws are kind of short and they don't have enough to grip onto these nuts. They should come through, it should be a bit longer. Makes me wonder if, in fact, there must be some other part, or this is just not a great kit. That's another possibility. Because there are no other screws that are long enough to actually make it all the way through. And we know we have to do that from this side because these don't come through far enough on this side to do anything. So it has to be that this is correct, and it's just hard to do. And it definitely shows you in the diagram really nothing at all, except that the fan goes on there. So, okay. Let's see if we can just get one on. If I could get one on, I would be so happy. Then maybe I could get a second one on. But at least at the moment, you can see it comes through, but not very far. If I hold it up a little bit closer to the top, and just maybe, the screws attaching to the magnetic screwdriver very nicely, but not attaching to the nut. And yeah, the nut fell back into the housing. I feel like I need just slightly longer screws, and this would not be so difficult. But then it might not be so tight. Is there a way to take off this housing, or to take off the no, the heatsink does not come off, and that is definitely, I mean, the only other way to do it would be if we could guide the screws in from the bottom, but you can see that's definitely not happening. And yeah, so this is just a slightly too short. Well, I'm afraid that I am losing enthusiasm for this part of the task. If I had a screw which is maybe a millimeter longer, it's just a really small amount of length that it's lacking. But that's just not fat enough, or sorry, that's just not thin enough, long enough. The heatsink is pretty solid, because it actually does, I noticed when it was running, it actually builds up quite a lot of heat. You know, like not, you know, burn up heat, but definitely like you could make a small pancake kind of heat, which is generally not what you want in semiconductors. Doing it sideways is also not the way, because gravity is not your friend. Well, I've given up on this fan for now, but we will put the side fan on anyway, because at least that way it will cool it somewhat. And actually I could probably just let this sit on top of the housing, and it will give it some cooling. Well, because I'm definitely too bored to keep trying to attach it right now. Now the case fan, the side fan, connects to some jumpers that are labeled for the fan, which it shows us on this diagram, which should be right above it on this long jumper here. And I don't see where it says case fan. Let's take a closer look at the, it looks like it is the, If you look at this diagram, the two pins are going side by side next to each other here, but that doesn't generally, most of the time, the jumpers on these types of connectors will go this way, not this way. So it makes me suspicious, because that would be more like, also these pins are labeled 5 volt, 3.3 volt, 5 volt, 3, ground 5, and it says to connect the fan on the side to 5 volt red and ground black. So that would mean that we would want to connect to ground, and then putting to this 5 volt right here. So, okay. And then it looks like this, does it go on that side or the other side? It would appear that it doesn't matter. It must matter. Oh, that is right, because we can see the fan is on this side and the connectors are on this side. So yeah, that would be right. And then that would screw into these holes here on the bottom of the case, using probably these smaller screws right here, of which we have also 4 of them. So at least we can attach something. But do we want to use those, or do we want to use these black screws? Well, we want to use the silver screws because there are, in fact, 4 of those, and there are only 3 of the black screws. Those must have a different purpose. So we'll use these little screws here, a little easier to get in, and then we'll screw down the board to the case. And you see that there's actually a nice little lip here for it to sit on top of. I think it was just those other screws that were just a little too short. If I get some longer ones, it should be pretty easy to put the fan on. And I should be able to do it without removing this from the case. So I've got 2 of them on. I'll add the 3rd one. And then the 4th one. Hopefully these are the right screws to put in this spot. If not, then I will disassemble it and reassemble it at a future occasion. Alright, so now we've got the board in. It's sitting alright. We don't have an easy way to connect this fan currently, but we'll just leave it there. So far, so good. Now going back to these, we know that this is the back and this is the front. And let's take a look at, this is the reset button and this was the power. And the power was connected. Maybe we can actually take this other fan out for the moment. So the power button was connected to where it was labeled on the side here. And this way we'll put it in the... That was probably easier to do when we could read it, but actually it is silk screen on both sides of the board. It's just a little tricky to read in this lighting, but we can do it. So the power switch goes in the front here, so that would be this. And it does say power button and ground right here, and then the LEDs for that, which we're going to the bottom of it, where the plus is the gray, and the blue is the minus, the negative. And then we have this other reset switch, and the reset switch went to where it was labeled system reset and ground, which is right here. This other one in between was the factory reset, which we decided we didn't want to do. And then if I put this on, then we have a case of sorts. All right, so far, so good. Now, actually not good because we have this sticking out. All right, now good. Now, there was a few more accessories that came with this kit that I think we should install before we put the case away. And the main one is this awesome Intel-made Wi-Fi. This is a Wi-Fi daughter board. It might also have Bluetooth on it, actually. I think, but it's a pretty powerful board. Where does it go? Well, let's look and see. Well, but really, where does it go? These are the connectors for the cameras. This allows you to connect two cameras. And usually we would be able to see the connector for this kind of board is very unique looking. It slips in and then it sits down. And then you screw it down with this little connector here so that the board doesn't move. So that's, but where does it actually go? Is there a picture of it on our diagram? Yes. No. No. Wait, yes, actually. And of course, the place that it goes is underneath the heatsink. Alright, so that means we're going to have to take this out and then, well, maybe not. You might be able to just remove the heatsink by these clips. I don't think so. Because you can tell just by looking at this diagram that this is the Wi-Fi board here. And you can see that it is sitting underneath on this side, in fact, right where the heatsink would be. And if I look in here, I should be able to see the connector Well, before we, oh yes, there it is right there. The board goes in at this angle underneath the heatsink. So we will for sure have to remove that in order, and it looks like we can just remove these two screws, and then, how about this clip? Hard to tell. This clip might just pop off. Well, I think we should take off the board from the case. That way we can get to it a little more easily. Remember I said that I was going to probably end up taking this out? Well, it was true. So we'll take these set screws out, take the board off again, and see if we can perform a little more brain surgery. And it's definitely not a consumer grade. When they say, you know, no user upgradable parts, this is usually what they mean. But I'm not just a user. Alright, so now we got that off. So we can take a little look and see how we can get the heatsink off. And it looks like we are going to have to remove those. Looks like if we remove those screws, we can just pop it off the top. Let's find out. If we unscrew these two screws, and oh yeah, it's definitely coming out now. Oh wait, there's a nut that just came off. Looks like there's screws on both sides. I see. I didn't want to take off the bottom screw, only the top. So let's put it back in before it gets lost. You can see that the top screw is moving. A little standoff here. Wow, it's actually really tight on one side and really loose on the other. Well, got one side off and the other one is going to play. Well, okay, we'll do it like this then. We'll take off the bottom screw, and then if I'm correct, we should be able to pop this out. There we go. Now I don't actually have to take off. I can tighten this screw down again, because we'll just tighten it from one side and then the other. It's one way to do this. Alright, so now we've got the processor off and we can actually get to the bottom of the board and we can install the Wi-Fi adapter, which was the whole purpose of this little exercise. So this is the Wi-Fi adapter here. So we can get a little better focus. And so we'll take that out. If you've ever changed the Wi-Fi adapter in your laptop, you've probably seen a board exactly like this. So it slips in this way. And then we use that little bracket to tighten it down. That way the connections remain tight, and in addition to that, the thing is really solidly attached. You know, if you decide to put this thing in a drone or an autonomous vehicle and the thing crashes, you know, you probably have a decent chance of it, you know, staying. So how does this piece go? Let's see if we can peek. Usually, oh, it looks like we would remove this screw and put it back in to tighten it down. So what is this piece for? You know it's for something, it's for something important. Maybe it goes over here. I might have to look at the manual. I'm not sure. It looks like, I mean, it's the right size to, maybe some of these require this as a clip, but maybe not this one. So if I take my screwdriver, remove this screw, carefully, and then put it back in, again, carefully. Oh, we lost it. No, just kidding. It's right here. And there it is. And it's really quite solid. You can see, I mean, it's not going anywhere, which is good. Because if we put this in the flying vehicle, well, not in this case, obviously. All right. So we've got the, and then where do we attach the antennas? The antennas are very important, and we have to connect those to the right spots. And I don't know the answer. Let us see. Okay, fine. We'll use the internet. So let's go and take a look about the Jetson Wi-Fi module. And this would be it. Uh-oh. Why do I have a bad feeling that I should have attached the antennas first? The hardest part is attach the antennas. Oh, whoops. And where do we attach these antennas to? To those little tiny connectors right there. Let's get closer. Those little tiny connectors right there are the two antenna connectors. And when we look at the actual antenna cables, we will see that those are really small. And we probably have to route them underneath the board carefully because we have to put the heatsink back on. So let's go and see what our erstwhile internet friend, he says tape them together. Okay. Let's see what JetsonHacks.com says. It also says, in the video it looks easy, don't believe it. Yeah, the connectors are tiny. Yes, no, I did know that. The thing is which angle to connect it to. Oh, yes, and also use some tape. Tape that was not actually included in this kit. It's a kind of protective tape that is going to prevent interference, which is usually a major problem when you're dealing with Wi-Fi of any kind. But let's just try to pop it on, just for the sake of saying we tried. Wow, those are small. And they don't stay on very well. Maybe if I got them on properly. Yeah, this is definitely going to be harder. And oh, it's on. Yes. Okay. Let's try the other one. I mean, I got this far. I don't want to give up now. Also, I have to transport this thing. So if I don't connect it properly, it won't survive transport. We got one. Can we get two? Not yet. Almost there. Stay on target. Almost there. Can we do it? No. It's a very small connector, and it's very important because without this properly plugged in, you will not have good Wi-Fi. And we need Wi-Fi. And it's not an internet thing unless it's got internet. It's just a thing. Okay, it's not. Oh, wait. No. No. Oh, they weren't kidding. The video makes it look easy. Don't trust videos. Isn't this a video? Yes, and don't trust it. Oh, no. Almost on, and then it was not. Because it wasn't really on. If it was actually on, it wouldn't have popped off. You couldn't hear it probably, but it made a nice little click. Like it definitely attached. Oh, no. Well, the first one did. Oh, wait, this one did not. It made a little click, but it didn't seat. Oh, no. I definitely don't want to break the cable, so I can't use much force. And if you don't get it right on there, okay, it is attached. But as they point out, you really do need that little piece of tape. I forgot the kind of tape. It's like Krylon tape or something. Kapton tape. Kapton tape, I believe is what it's called. So if we don't tape this on, then it won't actually stay attached. So we don't want to get too comfortable. I'm almost tempted to take these off. Just because I look at this whole assemblage and I think, how am I going to move this around without it getting destroyed? So, I definitely can't put the heatsink back on if I don't tape this down. So I think what we're going to have to do is take off these cables, as much as it pains me, and get that tape, and then make another attempt at this when we have all of the right materials, because if we don't, then we're going to damage this lovely piece of electronics, and we don't want to do that because we really need it to do interesting things. So I guess I'll just put this all kind of away. I'll pack it up later, and we can play with some other stuff and see if we can finish that up next week. Oh man, that was so cool. It was going to be so cool. We almost made it. Oh well. All right, so let's go back to some software. Apparently something I know a bit more about. Now that was a little tricky. I did not expect, as you probably noticed, I did not cheat by looking at this before. I just looked at it all right now. I did not cheat, and I also did not have time. So let's go over to GoBot. So what is GoBot? GoBot is a framework for programming physical computing type applications. It is the first of its kind in the Go programming language, and I introduced it at the first GopherCon, and since then it has had many contributors, and 127 contributors, plus people contributing to docs and other things. So it has support for quite a few different platforms, and the way that it works is the Go program runs on your computer, and then it controls some other external device, unless you're running on something like a Raspberry Pi, in which case it can use the general purpose I/O pins on the Raspberry Pi itself. So a lot of people use GoBot to fly drones like the Tello drone or the Parrot Bebop. And one of the things that it supports is a very cool little microcontroller called the DigiSpark. So the DigiSpark is an AT-Tiny 85, which is an 8-bit microcontroller that has only 8K of memory. And if you've seen any of my talks on TinyGo, you know that we have TinyGo support for this little board. It's the tiniest board that runs TinyGo. But you can also use it. You can see how it's a USB device where you plug it in. It's an actual USB pluggable board. So this board has the unique capability of essentially just being able to plug it into your laptop computer and give your laptop computer instant digital or analog I/O capabilities, because it's got a built-in analog to digital converter. This little adapter here that I made is to connect it to a servo. That way you can have, like a servo on a stick. Servo as a service. It's still coming. So in order to do that, though, we have to load some firmware on here that is called Micronucleus. And that lets us control it from our computer. And recently, GoBot received a new pull request, a new contribution from first-time contributor Gen 2 Thomas. Thank you for this, by the way. And this person, Thomas Kohler, added 2 different commits. One of them splits up the tests for the I2C interface, and the other one actually adds all of the tests. So if we take a look and we see how the DigiSpark actually works, the easiest way to do that would be just to view the entire file here. Oh, not the test, though. I want to view the implementation, which would be here under the file DigiSpark I2C. And if we view this file, so this is the I2C implementation for the DigiSpark, and it lets us send commands to it from our Go program running on our computer, and then read or write data from an I2C peripheral, which is actually connected directly to the DigiSpark through one of its pins. So your computer talking to the microcontroller, talking to the device. And so this cool person has added some capabilities. First of all, a bug fix for 787, which is that there's a bug in the read byte and write byte having to do with the missing start condition, which is needed for I2C devices to work correctly. And then also add some tests. So this sounds like it should be a very good thing to do, but we do want to make sure that it actually it does pass the tests as far as the automated tests, but it might be nice to actually run it on some real hardware. So how do we do that? Well, of course, we need to flash some firmware on our DigiSpark, and then we can write a program which will allow us to do that. So if I go to the GoBot website and we take a look at our platforms list and we look at the DigiSpark, wherever it's on here, DigiSpark, then this tells us how to install the little wire protocol on the board. And if we don't, which we don't already actually have it, we can use Gort. Gort is a command line utility which is part of the GoBot ecosystem, and Gort knows how to install things like firmware on the DigiSpark. So you can find more information on Gort at gort.io. So we can just download one of the pre-built binaries for Linux. In this case, we'll load the deb file, and I will keep it, yes. Actually, I don't even need to do that. I can just load the repository. It's been a while, but let's go for it. So I'll use GVM to go to my Go 1.16. Might have to make some bug fixes, but so be it. And we'll go into our Gort directory, and we'll do git status to see if there's any untracked files. Seems like so good. So far, so good. And I believe if we say, it's been a while since I looked at Gort. Let's take a look at the code. So Gort, of course, has a makefile, and that makefile has a build, and that build should build our binary. So if we say make build, of course it doesn't work because we are missing we're missing GoXC. So GoXC was a cross compiler that I don't know if it's still active, but let's see how we install it. This was written in the time before the Go modules existed. So I guess make deps. That will go and get the necessary packages, hopefully. Like I said, it's been a while since I did this. And it was before Go modules were introduced. A lot of the dependency management and things have already been solved by Go modules by adding a go.mod file and a go.sum file to your project. So, but that worked. And then make build. Okay, did not work. Ah, yes, because we need a Go module file now. So if I say go mod init, and we have to pass it a package name, which in this case would be, what exactly? I believe the package name for this would be GitHub hybrid group Gort. All right. That seems okay for me. That means that we'll, so now we go mod tidy, which will, ah yes, there was a change where the urfav fork took over for the Code Gangster fork of the CLI package, which is another package that's not even being used anymore. So, yeah, I knew that this might turn into something. I guess urfav. Oh no, let's see, where does that occur? Yeah, it's probably, we could probably change it. Oh, yeah, we could probably just change this. Let's find out if that works. No, but let's keep looking for the Code Gangsta. Very cool guy, Jeremy. Haven't seen him in a few years, but he did a lot of cool stuff early on in the, we should just replace them all. Code Gangsta with urfav. Is it urfav? I believe it's urfav. Let's go back and look. Oh yeah, it gave us the output. Yes, urfav. All right. So if we replace all of these, replace them all, then we hopefully can try this again. That time it worked. So now we should be able to make build. And it's doing something. Oh yes. So it built the, we probably could have just done go install actually. Because it did hit an error when trying to build for the Mac OS platform, which is not currently being supported by this. Let's just try go install, which might build the binary. Yes. So now if I just say Gort, all right, so that worked. I'll have to fix that dependency problem. So if we go back to the original task, which was that we wanted to use Gort to upload to the Digispark the little wire code, which will let us actually execute the code in GoBot to talk to this little microcontroller. So we should be able to run this, and oh yes, we have to, there's one more thing we have to do, and that is if we have to do Gort Digispark install to download the firmware, and then we can install. So that downloads the firmware, and now we should be able to upload it. And if we plug in our little device here to the side of my computer, the Micronucleus bootloader should detect it, and then it should be able to flash it. I'm not seeing it flashing. Maybe we have to flip it the other way. USB. Maybe this little adapter is not enough. Let's find out. Try plugging it in again. It's lighting up, but it's not detecting. Oh, yes. No, I don't have to do that. We could try a different adapter. Usually that's the answer. And of course I have several somewhere around here. Where's my bag of tricks? Ah, yes. My bag of tricks. In my bag of tricks I have a USB adapter. No, that's not it. I have a USB adapter. There we go. Let's see if maybe we plug in the USB adapter through this connector, and then we plug in. Will it do it? The light is turning on. Let's try this other Digispark that I have, just to see if, for some reason, it's definitely powered. We can even see that it's definitely powered because it's blinking the last program I wrote on the Digispark. But I have a feeling that this little USB adapter is actually power only. I have another one, even cheaper one, but that is for yet another kind of USB hub. Now luckily I think, I may have left that one at home. Too many USB, here we go. So I have another USB hub that's got a micro adapter. And so that one maybe will work. We'll find out. And nothing happened so far. It didn't even light up. This is definitely not the best USB hub I've ever tried to use. In fact, that's saying it nicely. Neither is this connector. But this other one was working before. I wonder, what does it not like? Let's just try plugging it in one more time. Actually, let's terminate this program and try running it again. It does not seem to want to flash. It's not my day for flashing. I wonder if have I done something wrong to my device? I don't think so. And we could try plugging into this other adapter. No, it's not happening. That's very unusual. This is usually a very reliable device, and of course I usually have another adapter. I have, oh wait, here it is. It's an actual Dell adapter. Plugged it in. Nothing's happening. Let's try plugging in the other one. And it's definitely not doing it. I wonder if I need a UDEV rule. So sometimes when USB devices will not be mounted, the reason for that is actually because you don't have permissions on that port. And, oh, of course, Gort not found because I didn't install it under CDOS. So the better way to do this would be to actually fix the UDEV rule. So what are we talking about? So under it would be under UDEV, etc., UDEV rules. We have a bunch of rules which control what happens when we plug a device into our computer. So in this case, what's supposed to happen is that this device is going to be mounted as a USB port, and this will allow the micronucleus to actually flash the bootloader, or the micronucleus bootloader rather, to flash whatever program, which is supposed to be, in this case, the LittleWire program, which is a program that runs on the DigiSpark and lets us control it from our computer. And it should have worked. And it didn't. So let's unplug and plug again. And no. It's not very cooperative today. I wonder if there's something wrong with my USB port. Because it's powering it, but it's not mounting it. This was actually the similar problem I had with the Arduino before, where it wasn't mounting it for some reason. Makes me think I might have to reboot my Linux computer. No! You know, I have not rebooted since I started doing this streaming. And rebooting now seems a little traumatic. But yeah, okay, fine. By next week, I promise I will have rebooted my computer, and I will have, done my laundry and eaten some healthy food, drunk some vegetable juice, and gotten some exercise. All right. Cool. Well, that makes it hard for me to test this, even though I am definitely confident that since it passes the unit tests, but I still want to try running this code somewhere before I say, yes, it's coming in. So, but let's let them know. I will test this PR over the weekend. Or let's just say in the next couple of days. In the next few days. Well, let's start out with thank you. Thank you, Jan 2 Thomas, for your contribution. I will test this PR in the next few days. That way he knows something's actually happening, because it has been some weeks. All right, well, I meant to actually get that merged, but apparently not. Darn. All right, well, that's okay. Because some people would like there to be a GoBot update, and I am one of those people. So next week we will finish this for sure, because we need to move all these projects along. Time, after all, is not on our sides. So let's see, what else can I do today that I was planning? Oh yes, so there's been an incredible amount of action in the world of TinyGo. As usual, every week. We did not get our release out that we were planning for various reasons having to do with running out of time. And now we're up to 124 commits ahead of release. We can see that there are some really cool pull requests that are waiting to be merged. One of them that I think is really quite interesting is adding this new parameter for WebAssembly features, WASM features. So there's a whole community of people using TinyGo with WebAssembly and doing really interesting things both in the browser and also running WebAssembly on servers in non-browser modes using WASI and other interfaces. Like there's a Envoy plugin that's written in TinyGo. And so I've been watching with great interest a lot of the work that people have been doing. And one of the things, I mean, it's actually completely amazing the number of hardcore developers who are really deeply into the LLVM compiler toolchain who come up on our channel on Slack, which I really recommend to you. That if you don't know about it, if you go to app.slack.com, actually just go to the TinyGo website and there's a link to it. And it's really, really great. The community, we are of 769 members. So there's been some pretty amazing work that's been going on in the world of WebAssembly and TinyGo. And so one of these things is benchmarking. The capability for TinyGo to do benchmarking is not yet landed. And where is this here? Or did it land? There we go. So DKEGL Fastly, must work at Fastly, has done an implementation of the Go benchmark stats. That way we can do some finer, more granular testing of the performance of TinyGo versus the performance of the main Go implementation. Some people say TinyGo is really slow. Some people say TinyGo is really fast, way faster than the main Go. I think both of those things are true. I think that if you're using maps, especially large maps, that the naive implementation in TinyGo is probably not the best one. Ika has mentioned this on several occasions, that it's an implementation we would like to revisit, but that is not first and foremost on our list. We're more interested probably right now in language compatibility than we are focusing on optimization per se. Although we're totally interested in optimization. If you have a pull request, we really like to review it. But it's not really our primary focus. It's more of a secondary. Our primary focus is really on language compatibility and the compiler itself. But we do know that a number of people have told us that some of the code they've written for WebAssembly in TinyGo is substantially faster. And we also know, both from our own testing and from some of our contributors and community members, things like the slow performance of the TinyGo maps implementation, which is, again, kind of a naive implementation. So hopefully this will let us lock down some of those numbers a little bit more concretely. So I'm really looking forward to merging that in. Another interesting pull request that was just opened yesterday from many-time contributor Ken Bell, who's done such amazing work, especially on the STM32 implementations. So this is a pull request to add chained interrupt handlers. So interrupt handlers are generally low-level hardware interrupts, are a signal from the hardware that the software needs to do something right now. Usually it's receiving some data from some type of hardware port, or that it's ready to send some data. And so the interrupt handling in TinyGo was substantially improved last year, but there's a couple of things that are still missing, and one of them would be the ability to add multiple interrupt handlers for the same interrupt, which it turns out is needed on, I forget which board he was trying to use this on, but in any case, this pull request has been submitted. it passes the tests, and we will definitely be reviewing it because that's a feature I think is really, really important for us to add for more robust and more complete implementations. And so as I was mentioning, I don't know, maybe we can find it if we do a search. So I noticed that there was a talk given, I believe, yesterday from, who was it? Famous person in Go? Oh man, mental blank. I hate when that happens. Nick Jackson, there we go. Nick is really cool and does a lot of really awesome stuff, and apparently gave a really interesting talk. Nick Jackson, WebAssembly, and TinyGo. So let's see. Nothing pops up. This was just yesterday? Oh, it's Nick with a C. Yeah, no, I spelled it right. Let's see if anything pops up. Maybe a tweet will lead to this talk. No, nothing pops up right away. Well, I will find out where this is, and I will make sure to tweet it on the TinyGo account. And if it says anything that is relevant to TinyGo or relevant to the TinyGo community that has to do with Go. But I know that Nick was very excited about some of the work that we've been doing in TinyGo. Also had some really great feedback and comments and things for us to work on, especially with regards to documentation around the garbage collector. So we're definitely going to be doing that kind of work. So what did we get done today? We got to check out the latest news from Mars and from near Earth orbit. We did a little bit of learning how to program in Go with good friend Lorenzo, who is actually quite a cool hardware hacker. I'm really excited when he is going fully speed on TinyGo and can make some contributions. We spent a bunch of time trying to put together the hardware for the NVIDIA developer kit, and then spent some time working on the DigiSpark. Found some errors in Gort, which I will be probably submitting a pull request so we can try to get that up to date. And then took a look at some of the cool stuff that's happening in the world of TinyGo. So on that note, I believe that is going to be it for us today. I'm gonna plug back in GopherBot and say to all of you, my dear friends here on the internets, have an excellent week, and we will see you next time. Same Gopher channel, same Gopher cave, same GopherBot, all new electronics.
Computer Liste, Computer Wette, everybody in the gas get flat. Computer Liste, Computer Wette, Computer Liste, Computer Wette, everybody in the gas get flat. Computer Liste, Computer Wette, Computer Liste,